Hello and welcome to Energy Efficiency. We are in the Global Energy Budget Unit. All right, we're going to talk about energy transfers, conservation of energy, wasted energy, and energy efficiency. Okay, let's get started. So what is useful energy transfer? Many household objects are designed to transfer energy from one form into another, and we've already talked about in the last lecture that energy is not created or destroyed, it's always transferred, okay? But we, as people that use energy, may find some energy transfers more useful than others. Okay, so if you're thinking about a fan, a really old fan, what energy transfer is an electric fan designed to carry out? Okay, again, at any time in this video, I encourage you to pause the video to think about the questions that I'm asking you, practice equations, rewind to hear what I said again. That's the beautiful thing about these videos, is being able to manipulate it in the way that you want to. Okay, so these fans are designed to get electrical energy and then transfer it to kinetic energy, right, in the movement of the fan blades. Okay, what energy transfer are these speakers designed to carry out? Okay, electrical energy to sound energy. What energy transfer are wind turbines in a wind farm designed to carry out? Okay, this is kinetic energy to electrical energy, right? So the movement, wind moving those blades, is creating electrical energy. Okay, what energy transfer is a hydroelectric power station designed to carry out? That's gravitational potential energy into electrical energy. Okay, it's the energy that we're capturing by the falling of that water, changing that water, changing the position of the water, changing in a gravitational field. Okay, so an energy transfer diagram shows the input and output energies for any device. Cambridge love these. You almost always have one on an exam. And this includes all the useful and wasted forms of energy. So for an example, in a television, you're going to receive electrical energy, and the TV is going to put out light energy, sound energy, and heat energy. Okay, so what are the main energy transfers in a radio? You're going to get electrical, which is transferred to sound and heat, right? And heat is going to be that wasted energy. The radio is not designed to create heat. It's designed to create sound. So the heat energy that it's putting off for us is not useful energy. Okay, what are the main energy transfers in a car engine? Okay, so chemical energy that you're getting from the burning or the combustion of fuel results in kinetic energy, which is movement of the car, sound energy, which would be considered wasted energy for most people, and heat energy, okay, also wasted energy. So how can we represent energy transfers? All the energy transfers, useful and wasted, that are associated with the device can be represented by a Sankey diagram. Okay. A Sankey diagram uses arrows to represent all the output energies, and the thickness of each arrow is proportional to the amount of energy involved at that stage. So if you're looking at the energy used in these light bulbs, you can see that in a filament light bulb, you have 100 joules of electrical energy input. Okay, and obviously, what's the point of a filament light bulb? Is to create light. You're only getting 10 of those 100 joules in light energy. The rest is heat energy. So that's why this arrow is so thick, because a ton, right, 90% of the energy that is being transferred in a filament light bulb is wasted heat energy. So then if you look at this diagram, Sankey diagram, of an energy efficient light bulb, 20 joules, it only takes 20 joules of electrical input to light the light bulb, which is significantly less than the 100 of the filament. Okay, and it's being transferred 10 joules into heat and 10 into light. So way less is being used, as well as less being wasted. Okay, so we talked about this in the last lecture, the law of conservation of energy. This states that energy cannot be created or destroyed, just changed in form. So we know that energy just doesn't disappear. Okay, the total amount of energy always stays the same. It's the same as in a chemical reaction. The total input of energy equals the total output of energy. Except for in a chemical reaction, it's the amount of mass that goes into a chemical reaction is the same as the mass at the end. Okay, so in most energy transfers, the energy is transferred to several different forms, which may or may not be useful depending on what the object is. So energy that is transferred to unwanted forms of energy is considered wasted. And obviously this is wasted for what we are using the device for. Okay, so what happens to the energy of falling objects? A falling object will lose gravitational potential energy and it gains kinetic energy. This is an example of the law of conservation of energy. Okay, because the gravitational potential energy that is lost as the object is falling equals the amount of kinetic energy that is gained. Okay, so if the roller coaster has 15,000 joules of gravitational potential energy at the top of the slope, how much kinetic energy will have gained by the time it reaches the bottom? And you guessed it, 15,000 joules. So this is assuming that no energy is lost by air resistance and friction, which we know is not a safe assumption to make, but it is a safe assumption when you're doing Cambridge problems on an exam. Once you get into a higher level of engineering, you would always have to take those things into account. Okay, so how is energy wasted? If you think about this cordless drill, it is transferring chemical energy from its battery into movement, sound, and heat energy. Okay, so kinetic, sound, and heat. The movement energy can be used to do work, but the sound and energy cannot be used to do work. So energy that does not do useful work is called wasted energy. Appliances usually waste energy as sound and heat. In fact, all electrical devices produce at least a small amount of heat when they're used, which is normally a wasted energy. So if a device makes noise but is not designed to make noise, then energy is being wasted as sound. Examples of devices that waste energy as sound include washing machines, dryers, blow dryers, a plane, cars, right? Like most things you can think of, most bigger devices that are noisy. It's wasted energy. If a device gets warmed, and it's not supposed to get warm, then that energy is considered wasted. Okay, and it's wasted as heat. So examples of this would include your cell phone, especially when it's charging or when you're using it a lot, and TVs, radios, cars, etc. So what happens to the wasted energy produced when energy is changed from one form to another? Remember, energy cannot be created or destroyed. Wasted energy spreads out into the surroundings, and this is called dissipated energy. So this dissipated energy is too spread out to be useful work, and so it cannot be reused. So for example, the heat and light energy that's produced by this light bulb are too spread out to be reused to do useful work. So they dissipate into the environment, surroundings. Okay, and this is a good segue into talking about energy efficiency. So efficiency is a measure of how good a device is at changing energy from one form to another. All devices waste energy. The efficiency device is never 100%. However, the more efficient a device is, the less energy it will waste. So an energy efficient light bulb is more efficient than a filament light bulb, which we saw in the Sankey diagram. And it's because it takes less energy and it wastes less energy. It converts a greater proportion of the energy that it is supplied with into light and not heat. Okay, so new electrical appliances display information about how energy efficient they are. And this greatly helps us to identify which appliance we want to use and which will use the least energy, which in turn creates less pollution and costs us less on our energy bill, right? Energy efficiency is not just about saving money, it's also about saving the planet. Appliances that are more efficient use less electricity, so then there are less fossil fuels that are burned in power stations. And it's important for reducing pollution and the effects of climate change. So the energy efficiency of a device can be calculated using this formula. Okay, energy efficiency equals useful output over total input. So this is a pretty simple equation, pretty easy to remember, and it's very useful. Useful energy is measured in joules. Total energy is measured in joules. And energy efficiency does not really have any unit. It's a number between 0 and 1, which can be converted into a percentage by multiplying your final number by 100. Okay, so let's look at an example. This filament bulb is supplied with 100 joules of electrical energy, which it converts to 45 joules of light energy. So take this time, pause this video, and answer the following questions. Okay, 55 joules of wasted energy. So that's wasted energy equals total minus useful. 100 joules times 45 joules, or minus 45 joules is 55 joules. Okay, in what form is the energy wasted? Heat. And what is the efficiency of the bulb? Okay, 45%. Again, if you want to look over these numbers, please pause the video. Okay, similarly, please pause and calculate. Okay, 32%. All right, that is it for calculating the efficiency of a television. Thank you for watching.